Hi there, hope you have a fantastic day. This lesson I will teach you probability involving tree diagrams. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, Sarah is learning about probability in class. She tosses a fair coin twice. So we need to complete the tree diagram first of all. So for her first toss, she either getting a head or a tail. So a head is done. So to complete this, so this is tail. And if the first toss, she getting a head, so the second toss, she either getting a head or a tail. So a head or a tail. So that's it, and tail is done for this. For the first toss, if she get a tail, so the second toss, she either get a head or a tail as well. So head or tail. So there you go. We're done with the tree diagram. Now we just list the sample space out. Okay. So this sample space here is head, head. So let me just write this down. Head, head. And then this sample space here is head, tail. So head, tail. And the next one is tail, head. So let me just write it down. So tail, head. And the last one will be tail, tail. So there you go. Part B, how many total possible outcomes are there? So we have head, 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 tail, tail, head, and head, head. So 4 possible outcomes altogether. So just write 4. That will do. Part C, what is the probability of getting 2 heads? So 2 heads will be head, head. This one here. So we have 1. So let me just write this down here. So the probability getting 2 head, that is head, head, is 1 out of 4. So there you go. Part D, what is the probability of getting 1 head and 1 tail? So it's in any order in this case. So 1 head, 1 tail. So head, tail, or tail, head. So 2 out of 4. So let me write this down. Probability of getting head, tail, or tail, head. So that is 2 out of 4. But then 2 out of 4, we can simplify this. So it gives us a half. So the answer is 1 over 2. There you go. Please stop the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through it with you. So to complete this tree diagram, so the first spin, so the spin either land on a red, a blue, or a green sector. So the green one hasn't filled up. So we just write this down here. So green. There you go. So if the first spin land on blue and the second spin will either land on red, green, or blue. So red, green, or blue. And if the spinner land on green, so the next spin will either land on red, blue, or green, right? So red, green, or blue. So there you go. So now part B, what is the probability of getting the same color? So first of all, we know that same color means this branch here, red, red, blue, blue, green, green. So there you go. So that means 3 out of. So let's count the total number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of the same color is, so we have 3 out of 9. But then 3 out of 9, we can simplify this. So that will give us a third. 1 over 3. So there you go. Let me clear this first. Now, part C. What is the probability of getting at least one red? So at least one red means we have red here, red green, red blue, or blue red and green red. So there you go. So let me write this down. Probability at least one red is 1, 2, 3, 4, 5. So 5 out of 9. So there you go. Let me clear this. Now part D. What is the probability of not getting any blue? So no blue at all. So that means red, green, or no blue. So that means green, red, green, and that's it. So that is 1, 2, 3, 4. So let me just write this down. So the probability of no blue, that will do, is 4 out of 9. So there you go. Question number 3. The probability that Emily is late for school is 0.1. The probability that Tom is late is 0.2. Their arrivals are independent. So part A, we need to complete these tree diagram first. And please take note. So Emily being late to school is 0.1. So therefore not late will be 0.9 because 1 minus 0.1 is 0.9. So let me just write this down. So that is 0.9. And please take note on this. This plus this must give me 1 whole. Okay, keep that in mind. And we know that the probability that Tom is late is 0.2. So therefore, not late will be 1 minus that. So that give me 0.8. So 0.8. And please take note again, this branch add up must give me 1 whole. Okay, keep that in mind because the probability add up must give me 1 whole. And if Emily is not late, so the probability Tom late is still 0.2. Okay, they are independent. So 0.2 here. And not late will be 1 minus 0.2 is 0.8. So there you go. That's it. Now, part B. What is the probability that both are late on the same day? So both are late will be late, Emily late, and Tom late. So late. So this branch, we time them together. Okay, so 0.1 times 0.2. So let me just write this down. So probability both late. That would do. That is 0.1 and we times 0.2. And 1 times 2 is 2. So we have 2 decimal places. So 0.02. Otherwise, just put on a calculator. Part C. What is the probability that neither is late? So both of them not late. So that means this one here. Emily not late and Tom is not late as well. So there you go. 0.9 times 0.8. So probability both on time or not late. That will do. So that is 0.9. We times 0.8. So 9 times 8 is 72. So 2 decimal place, 0.72. So there you go. Part D. What is the probability that at least one is late? At least one is late. So that means Emily late, Tom is late. Emily late, but Tom is not late. Emily late, Tom is late. So there you go. Because we want at least one of them late. Okay, one or more late if you like. So that means we have this time together and this time together, this time together, and we add them up. But quicker if we go 1 minus this branch here, because we do not want both of them late. Okay, so 0.9 times 0.8. So that's what that meant. So let me just write it out properly. So probability at least one late. So that is 1 minus 0.9 times 0.8. So that will give me, I'll just go 1 minus 0.72. So 0.28. So don't forget, because the probability add up give me one whole. So if we go this plus this plus this plus this branch will give me one whole. So we do not want this. So that means 1 minus 0.9 times 0.8. Okay, keep that in mind. Please stop the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through it with you. So we know that the probability of rain on Saturday is 0.3. So not rain will be 1 minus 0.3. Give me 0.7. So 0.7 here. And then the probability of rain on Sunday is 0.4. So that means rain on Saturday is 0.4 here. And not rain will be 0.6 because 0.4 plus 0.6 give me 1. So 0.6. So not rain on Saturday in here is 0.6. So there you go. Now part B. What is the probability that it rain on both days? So both days, so which means rain on Saturday and rain on Sunday. So this branch means 0.3 times 0.4. So probability rain both days is 0.3 times 0.4. So give me 0.12. Part C. What is the probability that it rains only one day? So that means rain on Sunday, but not rain on Saturday. Or rain on Saturday, but not rain on Sunday. So that means rain on Saturday, not rain on Sunday. Not rain on Saturday, but rain on Sunday. So this branch. So that means probability that would do is equal to, we have 0.3 times 0.6. We add 0.7 times 0.4. That is equal to, so just go 0.3 times 0.6. Then we add 0.7 times 0.4. So there you go, 0.46. 0.46. So there you go. Now, part D. So we need to find out the probability that it does not rain during the weekend. So that means Saturday, not rain at all. And then Sunday as well. So that is probability That is equal to 0.7 times 0.6. That is, so 6 times 7, 42. So 0.42. So there you go. Please stop the video and try this one yourself. Hi there, I'm back. How do you go? Let me go through it with you. So first of all, we know that her probability of scoring first shot is 0.8. So that means not scoring will be 0.2 because 1 minus 0.8 give me 0.2. So 0.2. If she scores first, her probability on the second shot is 0.9. So that means score on the second shot will be 0.9 if she scores first shot. Okay, so 0.9 will be here. And then not score will be 0.1. Don't forget, okay? So these two add up must give me 1 hole for this branch here. So take note on this. If she misses first shot, her probability on the second will be 0.5. So that means this 0.5 is done for you. So not score will be 0.5 here as well. Because add up must give me 1 hole. Part B. What is the probability that she score exactly 1 goal? So exactly 1 goal means score, not score. Not score, score. Okay, keep that in mind. So now we just work this out. So let me just write this, work it out we do. Okay, so the probability 1 goal is 0.8 times 0.1. So that one done. And then 0.2 times 0.5. We add 0.2 times 0.5. That is equal to, I just go 0.8 times 0.1. We add 0.2 times 0.5. So there you go, 0.18. Part C. Find the probability that she scores at least 1 goal. So at least 1 goal means this here, this, not score, but score. Okay, these 3. But easier if we work out by 1 minus this branch here. Okay, so it's quicker. Otherwise, we can work out the probability for this and we add them up. But let me just work out 1 minus not score, not score. So probability 0.2 times 0.5. Because 0.2 times 0.5 means not score, not score. Okay, keep that in mind. So I just go 1 minus 0.2 times 0.5. So 0.9. So there you go. Part D. What is the probability that she missed both shots? So that means this one here. Okay. Not score, not score. So probability misses both shots. So that will give me 0.1. There you go. Please stop the video and try this one yourself. Hi there, I'm back. How do you go? Let me go through it with you. So first of all, we know that the probability of defect for machine A is 2%. So that means 0.02. Okay. And then not defect will be 1 minus that. So 1 minus 0.02 is 0.98. So not defect will be 0.98. So keep that in mind. And for machine B, the defect is 0.05 because 5% means 0.05. So defect for machine B is 0.05. That is 5%. So not defect will be 1 minus that. So 1 minus 0.05 should give me 0.95. So there you go. And defect 0.05 here. And not defect will be 1 minus 0.05 is 0.95. So there you go. Now we can just work out the probability that both bulbs are defective. So that means both of them defect, okay? This. So there you go. So that is, let me write it down here, probability. So that is 0.02 we times 0.05. That is, I just go 0.02 times 0.05. So that is 0.001. So there you go. Now part C. What is the probability that both bulbs are working? So that means not defect, not defect. So that is this one here. So that will give me, that is 0.98 we times 0.95. That is 0.98 times 0.95. So 0.931. So there you go. Part D. What is the probability that at least one bulb is defective? At least one defective. So we don't want both not defective. We do not want that, okay? So that means 1 minus 0.98 times 0.95 will give us these 3 here. Okay, so let me just write this down. So the probability so that is 1 minus 0.98 times 0.95. So that is 1 minus 0.98 we times 0.95. So there you go, 0.069. So there you go. Thank you so much for watching. Bye.